What's going on, physics, algebra, blah. Rewind. All right, what's going on, Algebra 1 students? We're starting up class today, and we're kind of doing something new. We actually have physical students in the class, as well as some students online. So I'm really excited about that. And the worst part about being an online teacher is I don't know your names. You don't know how many times somebody comes up to me and they're like, "Hi, Mr. Dalday. How are you? It's so great to meet you. I've been watching you for like ever." And I'm like, awesome. I have no idea who you are because I don't hear your voice. I never see your face. I just see names. And I don't know your name, so when you just come up and say hi to me, you just be like, I don't know. So here's what we're going to do. I apologize if I'm putting you on the spot, but please introduce yourself.
Hey, I'm on the picture.
Well, you will be. All right. Who are you?
I'm Colette.
Colette. Okay, cool. Have I ever pronounced your name wrong?
I don't think so.
All right, good. I will make sure. But wait, people call you Coco, right?
Mm-hmm.
I like that name. What about you?
The server.
I'm Kaylin.
Kaylin. And people call you Kay?
Kay or Kai?
Kai or Kay and Coco. Got it. My wife watches Conan O'Brien. She's like all about him. And I guess they're a part of Team Coco. So that's what I'm going to think when I Conan O'Brien. All right.
I'm Tejas.
Wait. There we go.
Hi.
What's up, Tejas? All right.
Oh, hello. I'm Mario.
Mario. Cool. Cool name.
I'm
Oh, you're Makana. You know my brother's name was Makana? It means gift, right? Keely!
Sorry.
Yeah, it's an algebra thing. All right, but you.
I'm Justice.
Oh, you're Justice. Dude, how many Justices have you met? You've met 4? See, I've only met 1, and I had like this guy Justice in my class. I was like, he got such a unique name. And then like the next year, I have 2 Justices in my class. I'm like, dude, that's doing it justice right there. All right, and then who do we got? Your name, Keely. Come on. Oh, your name is Keely, obviously, because I told you your name. Cool. Welcome to algebra class. Today what we're going to do is we're going to basically, here's what I'm going to do. I'm going to split the class into 2 parts. I'm going to split up the class into 2 parts. I'm going to be doing 40 minutes where I'm basically going to be, wait 1 second. Let me do something real quick. And you know what? All of you guys over here, log out. Log out of the class. Everyone here.
Sorry for being around.
No. I'm sorry. I actually decided that you log out. Because you know what I'm realizing? Is that
You know we're present, so.
you don't need to see what I'm writing on the board. Because I'm writing it on the board. So let's just not bog down the Wi-Fi network. And let's just have you log out. That will free up some space on this Wi-Fi network. Get it to go a little bit faster. And I'm going to log out over here too. And then who's logged in? Can you see my face? Can you see all the people's faces over there? Yes? No? I guess. Can you hear my voice? And I always think it's hilarious when I ask, can you hear my voice? Because if you can't hear my voice, then there's no way that they would be able to answer in the first place, right? So it's like, if you're not here, raise your hand. Anyway, I don't know if you guys caught that joke, but all right. I'm saying, can you hear my? You know what I should do is learn how to say, can you hear my voice in sign language.
But if they couldn't see you, that would defeat the purpose.
You're right. That's logic. I'm just gonna type it. Can you hear me? Oh, my computer's freezing. No! This might be one of those classes where it might not be very fun if I don't get this thing to work. By the way, I have a question. Do you guys have printers? Are you guys having trouble with printing things?
No.
No. You're good.
No.
No? Okay. Because I actually went off and I call it my get rid of excuses thing I did this morning. See, this gets rid of excuses. You don't have a printer. Here's the first quarter. But I'm going to give this to people who really have trouble with printers. All right. To be honest with you, for those of you online, I super apologize, but I have no idea why this thing is not recording. Why this big blue button is messing up. And the guy who could fix it just walked in with that big TV over there. And then he left. So let me log out, log back in. This is my day. This is the way it goes. Sometimes I hate technology. You notice how I'm actually one of those online teachers who hates technology. I like using a camera and a big piece of glass.
Good choices.
What is that?
Good choice of school.
No, I think it is a good choice of school. Why? What's the problem with that? Huh? No. I just it's not that I hate technology, it's just that technology doesn't play nicely with me. I think it's because I push technology. Can you hear me now? Hi, everybody. Welcome. I'm back. I'm sorry. Hey, what's going on? Don't worry about it. Come on, sit up here. Mario and Tejas have a seat right next to them. I'm not trying to put people in the spotlight, although I did point the camera at them.
Right at.
Yeah, there we go. But anyway, I know I disappeared. I apologize. Can you hear me now? Can you hear my voice? Please say you can. Yes, awesome. Can you see my face? I didn't shave. You can see and hear. Awesome. Let's get this party started before this thing decides to crash again. By the way, Green Day. I love Green Day. Well, I know a few people who don't, but I went to go see them in concert a couple of times. Actually, I can one-up Green Day. Not one-up Green Day themselves, but I got to play music with them. It was pretty cool. Yeah, in a past life, I actually used to be pretty cool. In this life, I'm totally not cool, and I don't believe in like multiple lives. So I mean, I'm just not cool in general. I don't think that people figured that out back then. All right. Anyway, here's what I'm going to do. I'm going to spend 40 minutes doing our regular lecture because I want to get through the material. I pushed everyone's assignments back a whole week. You're welcome. Because what I want to do is give you guys a little bit extra time to kind of process the information I'm giving you. So all the stuff I'm lecturing on now, I think is due next week, Friday or something like that. Got it? And then next week, I'm going to be lecturing on what's coming up the week after. So you still have homework due every day, you know, or whenever I have it due, like 3 times a day,
Wait,
or
so
3 times a week.
3 isn't due till next.
I believe so.
Oh.
Functions 3 is not due till like the 29th or something like that. Don't quote me on that. Go check out the website, but I'm just saying. So I'm going to spend 40 minutes doing that. But I think that that's going to relate to this lab that you guys are going to be doing in your science class. And so what I'm going to do is I'll see if, for the next half of the class, I'll see if I can pull up a computer. And we will upload this program called Tracker, and we'll take a look at that. And I'll start introducing you to some concepts. Today, I think I'm going to introduce to you a concept that we use in calculus. And you guys are like, oh snap, I'm in Algebra 1. What are you doing teaching me calculus? And I'm going to say, yeah, but isn't that cool? Like, I'm going to try to teach you guys the calculus. And maybe you guys might hang, maybe you guys might not hang. Maybe you guys might hate me for it. But I think it'd be a really cool concept to kind of like start introducing to you. Cool? All right? Is that all right? And maybe, just maybe, you guys might actually say, wait a second. Calculus isn't as bad as I thought it would be. It's not this scary monster that I thought it would be. All right. But anyway, what we've been talking about is we've been talking about functions and we've been talking about lines specifically. Last week, or not last week, but on Wednesday, I went over the concept of y equals mx plus b. Can you guys see this online? Yeah? You good? All right. Y equals mx plus b. This is like the most general equation of a line, right? This is the general equation of a line. This can represent any line depending on what you change the numbers. And if you change this number, what does that change? Come on, you guys. Anyone online, you can answer. that changes the y. No. Don't say y, because I'm asking you. No, it's a joke. But if you change this number, the m, what does that change?
The slope.
This changes the slope, because the m is called the slope, right? And what do you mean it changes the slope?
The line itself, like the direction of the line.
Yeah. If a line is like this, you can't see the computer, then it's got a very little slope. But if the line is like this, then it's got a very big slope, right? It just changes the angle that the line is at. I kind of think of it as a hill, right? Like, would you rather walk up a hill that is this or this? This isn't even walking up a hill. This is like you got to pull yourself up with a rope, right? Which one would you rather do? Well, I don't know. Some of you guys are like, well, I like rock climbing, so let's do this one, right? But then,
Well, are there rocks on the hill or no rocks?
but then for the most part, I've noticed that most students are like, well, I'm lazy, so I'd much rather do this one, right? Yeah. Well, I mean, that's the way I notice you guys being. So, I mean, I'd rather do this one, right? This has a lower slope. It has a smaller m value. Cool? All right, now the b. What is the b? By the way, what is your name, Green Day?
Sarah.
Sarah, cool. I
I
love
was
you.
here last year. I just changed a lot.
That's right. I remember you. Just different hair. And
Yeah.
It's cool. I like it a lot.
Thank you.
Is it colored too? And cut? Ah, it looks good. The B, what does that do? What is it called? The base. That's what somebody's saying. But, yeah, absolutely correct. Sorry, close, but. B? I taught this to you Wednesday. 2 days ago? Most of you weren't here? That's your fault. You guys know? Alright, I'll tell you what. Just so that I know that you are not zombies or an illusion or figment of my imagination, say IDK or something I don't know. Or say, look, I'm totally lost. What is it? Alright? Say something to me.
I'm tired.
What is the B? I'm tired. That's a valid answer. I know you're alive. What is it? Come on. Say, you know what? I bet you I know what most of you guys are thinking. And I want you to say it. I'm scared. I don't want to answer because I don't want to be wrong. Right? Is that what you're thinking? I think I know the answer, but I'm too scared of you because you intimidate me. Go for it. Say it. Okay, good. At least I got a head nods out of you. All right. I'm dead. That's a good one. Yeah. At least I know you're alive. The B is this thing called the Y-Intercept. What does the word intercept mean to you?
Is it where the line intercepts the y-axis?
It means where it crosses, right? So the Y-intercept is where the line does what?
Intercepts the y-axis.
It crosses that Y-axis. That's it. Okay? If I have a line, let's go with purple. Where the Y-intercept is right here. Because the Y-axis is right here. Does that make sense? This is the X-axis, by the way. If I were looking for the X-intercept, where is that?
At the bottom.
Up, down, where?
At the bottom
Down.
on the left.
Down. Your left.
Yeah,
Okay.
right there.
Perfect. Awesome. You guys get it online? But wouldn't it be a non-function? What are you talking about, Raven? What's a non-function? I don't understand what you're talking about. The graph. Oh. No? That graph is perfectly a function. In fact, do you remember I made you guys learn a test in order to check whether or not it is a function or not, right? You guys remember what that test was? It's what? The vertical line test, right? And in the vertical line test, what kind of line do you use? The vertical line, right. Someone turned in a homework assignment where they used a horizontal line. I'm not going to say who, but I'm just saying it's called the vertical line test. Got it? All right. So, this is the Y-intercept. Let's talk about this thing real quick. There's something you can tell me, Garance Barents, about the Y-intercept. And we haven't even started class yet. We're just starting to talk about things. the y-intercept has all of these points have coordinates, right? A point here has this as an x-coordinate, that as a y-coordinate. What can you tell me about the coordinates of the y-intercept? There's something you do know for a fact, guaranteed. Say it.
Y-intercept.
What is that?
It's on the y-intercept.
It's on the y-intercept, but what does that mean? If I were to describe this point, I have to give me 2 points.
The x is only 0.
The x is 0. The y is
3.
b. I don't know what it is. It's just some number. You got to tell me what it is. But I know, I can guarantee you, Garants Bobarans, boom, the x is 0. Because that's how we define the y-intercept, right? The y-axis is where x equals 0. See? This is where x equals 1, 2, 3, 0 is right here. So the x does have to be 0, okay? Because I might ask you, and I might be a punk, and I might say, I'm going to give you some equation, figure out the y-intercept. And how would you do that? Go for it, Mario. You said it. How would you find the y-intercept if I asked you the y-intercept, but I gave you the equation? I said, y equals 3x plus 4. You know that at the y-intercept, what has to be true?
X equals 0.
X equals 0, so what should you plug in?
4.
Well, no, you just plug in a 0
Oh, yeah.
for x. And you're right, it's 4. Because 3 times 0 is 0, and plus 4 is 4. Does that make sense to you?
Yeah.
We cool? You like it? You dig? Awesome. Good. So, that's kind of a warm-up. That starts us off. Are you guys excited? You guys excited to be here with Mr. Dalde? Is he as stinky as he smells on camera when you guys are in virtual class? That's a joke. I don't think you guys get it. I don't think my jokes ever come across correctly.
Just your enthusiasm.
Yeah?
Yeah.
Does it? I don't
Comes
know.
across.
It does it?
It
Okay.
really
Anyway, what we're going to do is we're going to be covering this page, and you guys don't need to write anything down. You guys just might want to start taking this stuff, because I'm going to do you a big favor, and I'm going to start doing some of your homework for you. You guys are like, sweet, I love it when he does my homework for me. There are many ways to represent a graph, or represent a function, correct? One way is you can talk about it. Remember, Tejas, we had that whole discussion about Redbox movies and renting iMovies and all of that kind of stuff. So you can talk about the equation, and then that will kind of give you a good idea of what that function does, right? There's another way to represent a function. It's in a bunch of numbers. We call that a table. And you make these tables with 2 columns, and it's kind of this boring. What's going on, other Justice? Which is crazy. I hate to say it, but Justice D, you might have to be known as either Justice D or Justice 2. Because that's Justice P.
I don't have to be P.
Because that's your last name. Or you want to be the
Can I-
number
can I-
one
can I just
Justice?
say Batman? Can my name for the
Can I just call you the Hammer?
What?
You'll be the Hammer of Justice?
How about Thor's? How about Batman? Can I use Batman?
Alright, fine. Fine.
I'm Batman.
We got Batman up in here. Justice, is that alright with you? Do you want to be called something else?
No, it's fine.
Because I got Coco over here, and Kai, Batman, and JD. JD.
Wait, who's Batman? I missed the whole
Batman is Batman right there. I'm
No, no,
Batman.
no.
He did it.
Okay, there you
He
go.
totally did it. I'm Batman. Anyway, one of the funniest things I saw the other day was there was like this security camera of this police station, and then like this guy in a Batman costume comes in and drops off a criminal and just walks away. I was like, sweet, that's justice right there. He got put in by Batman. All right, anyway, one way is talking about a function, right? Another way to describe a function is you give a bunch of numbers. You make a little table. We usually make our tables like this, x and y. We put in an x, we output a y. We put in another x, we output a y. X, y, x, y, x, y. Is that hard? Not really that hard. Is it tedious?
Yeah.
Yeah, tedious. Don't really like it, but I mean, it's easy to do. It's just, I don't like doing it. All right? Another way is an equation. Okay? And then the fourth way is a graph. There we go, graph. Now, what we're going to talk about today is if you're given the graph, how can I figure out what the equation is? Or if I'm given the graph, how can I verify that this is the right equation? So we're going to try relating those two to each other. That's the game we're going to play. And to be honest with you, that's the game we're going to play for like the next 5 weeks or something like that. So learn this game because it's not going to be that bad. All right? There's your basic overview. Cool? So let's take a look at this. I'm going to erase. You guys ready? All right. Here's one of your homework problems. So you might want to write notes on this. I'm on page 5, I think, on 3.2 symbolic whatevers. All right, let's see. I think let's just start on number 4. We got y equals 2/3 x plus 2. Okay? How's it going? I'm Mr. Dalday. What's your name?
Tyrell.
Tyrell. Awesome. That's a cool name. It really matches your like backwards hat, like muscles out kind of motif you got going there. All right. Anyway, what is Raven saying? I can't really see them. All right. So we can do, from this equation, we can make a table. So let's make our table. So we have x and a y, and they provided one of the x's over here. X equals 0. By the way, I'm just wondering, if I plug in x equals 0, what value is that going to give me? Not what. All right, what value is it going to give me? Go over it, Mark.
The Y-intercept.
The y-intercept, right? Because we know as soon as we think, oh, x equals 0, that means we're going to find the y-intercept. What is the y-intercept in this particular case? Say it out loud. Be confident with this one.
2.
2, there we go. It's easy. You just plug in 0 into here, 2/3, and blah, blah, blah. Bada bing, bada boom, everyone's happy. I have a terrible Italian accent. I actually am not Italian, which is why I would have a terrible Italian accent. Raven wants to choose the next, and the next value you can choose is another value. Raven suggested that we choose 1. Fine, 1's fine. You plug in 1 over here. That's 2/3 plus 2. Okay? That's 2 and 2/3. You like that lazy way of doing it? I guess you could calculate it out and just make that like, what is that, 6, 7, 8, so 8/3. If you like, working with those kinds of fractions. Or you can make it 2.66. 2.67, or 6, and then you round it off to 7 or something like that. You can write all that stuff. We cool? To be honest with you, Raven, I probably wouldn't have chosen 1 for my x value. Keely's going like this. Why are you doing that?
Because I chose 3.
Keely chose 3. Tell me, somebody else besides Keely, why would Keely choose 3? Yeah, Raven's saying why not? Why would you choose 3?
Because that's the easiest to do.
Why is that easier than 1? 3 is a bigger number. What?
Or 0.
0's way easier. 0's the easiest, all right? So, let's just get that. That's the easiest. Why would you choose 3? What's up, Justice? JD?
You multiply 2/3 by 3, it comes out to 2.
Yeah, because it kills that fraction. I totally agree with you. I hate fractions. I don't know if you like fractions. I hate fractions. But if you like fractions, you're probably the kind of people, I don't know, what kind of American are you? You have 2/3, you multiply that by 3. That 3 gets on top, gets killed by that 3 on the bottom. You have 2 just left over here. 2 plus 2 is pretty easy to do. That's just 4. Cool? Does that make sense to you?
Can we keep it 2 and 2/3?
You can do whatever you want.
Okay.
I told you can choose whichever one you want. Why don't we do another one of these? Do you see these as hard or what? And I think Leanne chose 7. Leanne, I have no idea why you would choose 7. You could. You totally could. You just multiply this, 7, that's what, like 14 over 3, turn that into common denominators. And, yeah. That's fun. You're probably the kind of person who likes pain. All right. Can I erase? All right, cool. Do you need another one of these, or can you do the rest of them by yourself? Are you unsure of this one? What's your
I'll
thoughts?
answer for the class. Another one.
No, you don't want to do it. All right, fine. Since he's answering for the class, I'm fine with that. By the way, if you guys were like, no, I really want to do another one, then speak up next time. All right,
I
let's
said
see.
another one.
Oh, you want another one?
I said another one, not another one.
All right, fine. Let's do this one. All right. Why don't you choose, Mr. Tejas?
Okay, let's choose a scary one.
Oh no.
Which one?
The left second.
Second on the left. Y equals negative x plus 4 over 2. This is the scary one.
It just looks scary. I know
You're
it's
right, it
not.
does. It does look scary. I totally agree with you. They told us to choose 0 for the first one. If I plug in 0 here, that makes it negative 0, which is also 0, plus 4, that's 4 on top, divided by 2, so that's perfect.
Cool.
And this right here, Mario, is the
Y-intercept.
It's the Y-intercept. Right. You guys are getting this, right? All right. Thanks, Mario. You're my guy for that thing. Choose another X. What do you want? It's up to you. 2. 2 is good. 4. All right, Keely, you chose last time. Let's make it 4. If I plug in 4 here, I got negative 4 plus 4. That's 0. 0 divided by 2 is still 0. So we got 4, 0. Interesting. That's cool. Justice. Oh, Batman.
Batman votes 10 because that's a good number.
10 is good number. 10 is good number.
10 is good.
10 is a good number.
10 is a good number. When you plug in 10 over here, you get negative 10 plus 4. That's positive 6. Divide that by 2, that's 3. Alright, anyway.
Batman agrees.
Batman agrees.
Batman approves.
I am Professor Batman, yes. I have a question for you. This says 4, 0. I'm just wondering what your thoughts are. Is there a special name for this particular point right here? Think about it. And I'll give you a hint. I might be looking to Mario for this answer, but I'm not going to ask Mario because I want you guys to think about it. But Mario's kind of been my guy on talking about what this is. There's a special name for this particular point right here. What is that name and why do we give it? Double x is v equals, wait. I want to see what Raven's saying. V equals y equals 0. This is saying y equals 0. Yes, you're right, Raven. This is saying y equals 0. By the way, Sarah,
Yeah.
would you like them 15 minutes early? Is that enough time? You
If
said you wanted
possible.
extra time.
Yeah, if possible.
Yeah,
10:15.
or I'll tell you what I'll do is we'll start your class, and I can even help you a little bit out with the math part, and that way I feel like I still got my full time.
Sure, let's do it.
So,
I can't start too early though because I have virtual kids logging in at 10:30. Right?
all right. So you're gonna start them. Oh, you're gonna start them at 10:30. Okay, all right. So I'll give you 15 minutes early. Cool. All right. What is his name? All right, I'll give you a hint. What is this name? What is the name of this point right here? Why? Because I'm asking you. What is the name of this point right here? That was a joke. I don't know if you got it.
I got it.
It was funny. I got it. It just wasn't funny, and I'm not going to laugh at your jokes.
Haha.
All right. We'll laugh at Batman's jokes. What is the name of this point right here?
Batman's over there.
Come on, Mario. Oh, yeah, you can answer.
Oh, it's
Just blow it out.
It's Y.
I'm not angry at you.
It's Y-intercept.
This is the Y-intercept. Why is it the Y-intercept?
Because it's where it crosses
Because
Y.
Because can. Because what?
Kind of, yeah.
This tells you why it's the Y-intercept. Because what? Go for it.
Oh, it's where it crosses the Y-axis.
It's where it crosses the Y-axis, and we know that where it crosses the Y-axis, x equals 0. Right? I told you that this is a special point right here. The bottom one. This is where y is equal to 0. What should we call that then?
The X-intercept.
Yes! That's exactly it. Say it louder.
The X-intercept!
It is the x-intercept.
Woohoo!
And I'm so excited. My voice squeaks. Yeah, it's the x-intercept. Exactly. Very good, Raven and Tejas. That you guys said it pretty much at the same time. Yes, it's the x-intercept. I'm just letting you know. I mean, like if I asked you to find the x-intercept, then what you should probably do is plug in where y equals 0 and then figure out what x is. Does that make sense? Tejas just so happened to choose an x value that gave us y equals 0. So therefore, we can identify that point as the x-intercept. Does that make sense?
You're welcome, everybody.
Yes, you're welcome. Moving on. Let's go to the next page. Let's try some of these harder ones. Okay. I'll tell you what. Let's take a look at this. Actually, you know what? I'm going to unerase what I just erased. On the computer, I have an undo button. On this one, I don't. All right. Let's take a look at these graphs right here. And let's graph this point right here. Let's graph this equation. So I gave it to you as an equation. I gave it to you as a table. Now I'm going to give it to you as a graph. And I'm running out of room here, so I need to... There we go. If I were to graph this, I know that this point right here would work. Because that's the y-intercept. Did you change your shirt?
Pardon?
You changed your shirt?
I'm presenting today.
Oh, no, I just thought I was going crazy. I wanted to make sure.
We weren't moving. He's
We're
saying
all
your
going
shirts.
crazy. Yeah, I
Yeah.
know.
All right.
Welcome to science.
Do you understand why I put a dot right there for this graph?
Because that's
Because that's
Number
what the
two.
y-intercept is. It's that 2. And I go back 4. 1, 2, 3, 4. Put a dot there.
that's it.
Yeah, if I were to graph it, it looks like that. So the next page is asking you to match the graphs to the equations. Well, if you have some points on there, then I'd be pretty happy on these equations. Are we cool with that? You like this idea? This is a solid concept for you? By the way, I'm just gonna ask. I'm gonna put this guy on the spot. Manny Tate is our biology teacher. You're our like elementary biology teacher, but you're a biologist
Yeah.
to begin with.
Yeah.
Do we use this stuff in biology, or is this just like, why should I learn this? Because it's an exercise we do in math.
In terms of understanding slope.
Slope,
Yeah,
graphs.
I mean, look at it this way. If you guys have, let's say, cancer, right, and actually take a biopsy of your tumor. You get a biopsy, right? It's a small piece of it, and we see, try and figure out what kind of cancer it is.
You got to speak
if
up
it is
loud.
cancerous. Okay.
I know you're
sorry.
way louder than that.
Hi. So so we take a sample. It could even be your blood, but let's say cancer cells, right? So my job will be to get this biopsy from you and try and grow out these cells on what we call tissue culture. So the growth rate of those cells, right, proliferation, big word, growth over time, is managed or actually observed using these tools on the board. So every graph and every chart and every table you create, I mean, these are very, very valuable tools. Just as valuable as measuring tapes and scoops, right? Things like this, right? But these are extremely valuable tools because they show that something's happening over time, right? Time doesn't stand still last time I checked. So as long as time is moving, something is changing or not. Now, if there's no change, then perhaps this tumor, whatever, is not growing, and maybe it's benign.
But that's a good thing.
That's a good thing. We want benign, right? But if it's metastasizing, it means it's actually growing at an increasing rate. It actually move into other parts of your body, your bone marrow, which is terrible, right? And other parts. So understanding these XY coordinates, you see them, and I used to land a lot like you guys. I see them as points in time, right? And a line on the board. But each one of those points, if you think of it as as cell growth, or you think of it as number of, let's say that it's a negative slope. Here's what a negative slope is, right? The line goes what? Down, right? So look at the negative slope. So how many of you guys eat poke or fish, right? Within the next 40 years, the larger fish populations such as tuna will be, at the rate we're consuming now, they're crashing. If you see a chart or table like this, XY coordinates, when X is whatever, Y is whatever. If you look at that graph, it's showing right now we're capturing and collecting so much tuna that the graph is showing just a nosedive. So every time we go to the store, tuna used to be, when Tosh and I were younger, 50 cents a can.
Yeah.
What's it now? $2 a can. So the more that it keeps crashing down and that graph is going, showing that line, XY coordinate going down, the more the cost of tuna is going to go what? The slip, right? So, and think about the human population. It was like this, and then did what? Right? Is that an XY coordinate? Of course it is. Right? So these are extremely valuable tools that help us understand our data. Right? Understand the change of something over time. Really valuable. I would say I can guess what a half a cup is, but there's no way I could do without that. These charts and tables. You guys get that, right? People die if you get these numbers wrong. Right? Things happen if you don't understand these graphs. So don't see it. Matter of fact, let's even get away from biology. Money. Get into economics, right? Make a mistake on the numbers and the growth rate in your economy can have a devastating effect on the United States. Sure it can. So really pay attention to this. Don't just see it as numbers on a board. See it as your pocketbook. See it as the food that you eat. See it as a tumor that you hope that your grandmother does not have, right? See, make it real to yourself. Only then does it change its face from what if those crap and numbers on the board to, oh my God, I know how to manipulate these numbers or just make a graph that helps you better understand what's going on with my own health, right? And the health of the environment. Make sense?
Awesome.
So make it real.
Thank you.
Make it real.
So you heard it from the mouth of a scientist.
Yeah.
This actually does make sense. You guys hear that? Learn slope, cure cancer. Don't learn this.
Learn slope.
People die.
Learn slope and retire young and take your millions and invest it in philanthropy to help people like us, like you guys, who are future scientists, find cures for diseases, right?
Yeah.
So,
We're actually double teaming them with I'm teaching them slope. Manning's telling them how it's relevant to biology.
nice to meet you guys.
I truly apologize. I forgot your name though. What was your name?
Trey.
Trey. That's it. Cool. Welcome, Trey. All right. Check this out. Here's what I'm going to do. I'm going to take a look at this problem right here, and I'm going to kind of ask you a few questions about it. I have a graph. Here's the graph. I think, let me just kind of make sure I got this is 40, this is 60, this is 80, it goes all the way up to 100. And then they gave us a few points over here. This is 84. This is 86, 88, goes up here, 90, 92. I guess we're going up by twos. This one goes up here. It looks like that. It goes on forever over here. And they put a little double line right here. What do you think that double line means? Any thoughts?
The graph can leak out.
What is that?
I'm kidding, never mind.
No. You were onto. I knew you were onto it when I put down 84, and you were like, wait, what? Because usually it goes 0.
I said the graph can leak out.
Yeah.
I meant like the graph can go on from there. So it's
Yeah.
It's
just
stopping there and starting.
Yeah, that's all it means. Is I don't want to have the graph all the way back there, so I'm just going to put a little double line there and say it continues that way as well, and it continues this way as well. Are we cool? And then the lady apparently guessed that the graph is y equals 5x minus 380. To be honest with you, I have no idea whether or not she's right. In fact, I have no idea whether or not she's right, so much so that I want you to tell me, is she right? And how would I prove that she's right? So, I gave you the graph. I'm giving you the guessed symbolic representation of the graph. Now I'm going to ask you, how would I figure out? Okay, I'm on page 6. But this is more of the discussion on it as opposed to like I'm going straight off of this stuff. How would I figure out whether or not this equation matches with that graph? You guys have any ideas? Plug in what?
Numbers.
The numbers. Okay, good. No, you're totally on the right track. Keely, say it out loud.
You have to plug in the numbers.
Plug in the numbers. What does she mean? She's on the right track. She's got it. Kind of. Just give me more details.
Like the X.
The coordinates. And Raven's saying the coordinates. Come on, help her out. Help her out. We're giving you big hints. Keely says plug it in. Raven says the coordinates. Come on, Tyrell. I see you thinking. I see you're like, I got the answer. I just don't want to say it because I'm so smart. What is it? What is it, Keely? You did the thing.
It's fine.
No, it's not. It's not a dumb thing. Say it. You got it?
Because like it's FX and X. You just put what it is and see if it works out.
Okay. So what you're saying is this part over here is fx, which we also know as y, right? And this part right here is x. Can you tell me one of the points that are on this line? Just give me the coordinates of it. Any point. There's many. There's infinite amounts, but I'm just looking for one of them. Now, all right. Remember my deal? If you don't know, at least just say I don't know, or I'm too scared to answer, or something. Just say something, because I mean it makes me feel like you're alive if I say, do you know? And then, okay. What is one of the points?
84 and 40.
There we go. There's a guess. 84 and 40. Okay. Does anyone else say I don't know? 84 and 40. All right. Let's take a look at 84 and 40. Do you guys agree?
Sure, why not?
Sure. Why not? No, Sarah, you're actually nodding your head. How do we get 84 and 40?
It's a point on the graph.
It's this point right here, right? X is equal to 84, y equals 40. Do you guys see now how to get a point? Then give me another one. Keely, don't answer.
80 and 90. It was, no, 92.
92. All right, you said 80, 92.
Yeah.
Okay. That is 100% wrong. Sorry. It's close, though. She gave me 8440. You gave me 8092. If I were to graph 8092, I'm just going to show you right here. The graph would probably be somewhere around here. That's where 80 is. X equals 80. 92 is way up here. That point is not on.
Oh.
Because it only starts at 84.
No, well, it starts. It can go on. Like you said, it could leak out that way.
Yeah,
But Batman's onto something.
92, 80.
9280. You gave it to me backwards. When you do coordinates, you always do the x coordinate first and then the y coordinate. Now, that's great. I love that you made that mistake because now you won't make it again. And hopefully, people will think, wow, he really ridiculed Justice back there. I don't want to make that same mistake. So don't make that same mistake. Get the x first and then the y. Right? So 8440, 9280, good. What's one more point? Justice and, Batman and Keely, sorry. There's two justices apparently, so the other justice wants to be known as Batman. All right, Batman and Keely, you can't be answering. What is one more point? Go for it.
80 and 60.
8860, awesome. Do you guys see how this game is played?
You just say the points.
Yeah. All right, so we've now made a table, right? We got 8440. We got 8860. We got 9280. X, Y. Got it? Now, how can I verify that these points line up with that equation? Go for it, Mario.
X0 equals -380.
Mario said if I plug in x equals 0, that equals -380. I'll be out. That is terrible 80. Sorry. I'm not used to writing like that. And you can't even see it on the computer screen. All right, there we go. If Mario said if x equals 0, y equals -380. That is according to this equation, right? But that doesn't tell me whether or not this graph is the same as that equation.
But where'd the 5 come from?
Where'd the 5 come from? How can I figure out whether this graph, which we know is associated with these points, how do I know that this matches exactly up with that? Keely.
You would put the 84 times 5 and you put the 40 and the y and you see if that equation equals 40.
Good. Let's see if it's true. This is our check. So let's plug in 84. Let's plug in 40 for the y. So 40 equals 5 times 84 minus 360. Anyone got a calculator? 380? I don't got a calculator in my head. You got one, Justice? All right, help me out here. 5 times 84. 420
8 equals 40.
minus 380. Tejas,
40.
your brain, 40. Awesome. 40 equals 40. Is that true? Yes.
Yeah.
So there, because that's the 40 from this side and this is the 40 from that
Yeah.
side. It's 40 equals 40. We're good. That point does work. I mean, you might want to check more than one point, because if you're doing a line, you need more than one point, which is actually going to be the point that I make with what I'm going to start teaching you with Sarah. But do you understand? You understand? Well, this is what I gave you. Do you understand how I got this? Yes, everyone? Coco? Kay? Tejas? Sarah? Mario? Okana? Trey? Keely? Justice? Batman?
Are you asking us or
Tyrone?
remembering names?
I'm trying. I'm doing both. We good? Because I'm terrible at names. All right, Raven, could you switch the page on the computer? Oh, you're right. I'm sorry. We're doing this problem, and we're verifying. We're actually doing page 7 because we're verifying that this is correct. Do you understand how to get from here to there? And now you understand how to get from here to there. So do you guys agree that this is the equation? Yes. This is the equation of that line. Now once we have that, it asks you find the y-intercept. How would you do that? Mario already did.
Sorry.
So somebody else besides Mario said it. In fact, my head's covering it.
No, it's not.
Well, it is on the camera. So now that we have the equation, how do I find the y-intercept? Think about it. It's tough. Someone say it, please. You guys are making me look like an idiot doing this.
0.
Will you do what? What?
It's 0.
No, it's not 0. The y-intercept is not 0.
I'm sorry.
It's 380.
Oh.
But how did I get 380? Actually, it's not 380. Negative 380. How did I get that? Right, Raven? Exactly. It's negative 380. How did we get that?
X equals 0.
We plugged in x equals 0 because when you want the y-intercept, you plug in x equals 0. When you want the x-intercept, what do?
Plug in y for 0.
You plug in y equals 0. That's how we get those intercepts. That's how they're defined. Does this make sense to you? Good. I see. That's what I love about teaching live people is I get to see this. Oh, that's what I live for, and I really just man, to be honest with you, if you guys can start conveying that on the chat, like I want you to develop a culture where you guys actually just say IDK, I don't know, or I get it. Oh my goodness,
It's like the 2 dots
right?
below.
Right, give me something, because I'm teaching this to you, and I'm like, isn't this amazing? Isn't this exciting? And you're like, no typing, too lazy. But get excited with me. Okay, do you guys get that? Do you understand this? All right, I'm going to teach you guys something that actually has to do with calculus because now I'm going to kind of switch brains and say, all right, now I'm going to switch modes. I want to get you guys a little bit ready for this lesson that we have coming up. Do I have enough time? Yeah, I do, right?
Yeah.
All right, I got about 15 minutes. I'm going to teach you guys a calculus concept. And you guys are like, oh my goodness, I'm learning calculus. And the curriculum director, who is sitting in the back, is saying, what is he doing teaching them calculus? And I'm going to say this. I think that you can learn this particular lesson. Okay? What you're going to be looking at in science class today is you're going to be looking at graphs. You're going to be looking at your cars that is going to be going, right? And so it's going to go straight like that. And I think you even be analyzing a little toy car that goes, just kind of a constant motion. Got it? So like, if I were to graph that out, and this were time, and this were x, I know it's weird because x is now up here, but that just means distance. If I have a meter stick out here, it just means how far it went. And over here is time. You guys get it? This would be the graph of something moving in a straight line, just kind of on the chalkboard, constantly going that way. Agreed? Everyone agree? Yes? Yes? I see some heads nodding. Awesome. Say it. Say it. I agree.
I agree.
Awesome. Awesome. Good. I got a question for you. I got another car that looked like that. You can't see that on the computer screen, so I'm going to draw it a little bit darker. Looks like that. Which car won the race? The purple car or the black car?
Purple one.
The purple one. You say it with conviction. You said it with conviction. No, you finally answered me. You're like, oh, it's a purple one. Why?
Because it arrived at its point faster.
Okay. Maybe this is the point where you need to win the race, and it got there in less time. Okay. All right. Or can you? Which one's moving faster? There's your question for you. The purple one, right? Why?
Because it's inclined.
Because it's incline, which we also know as the word. In fact, it's the first word I actually taught you today. Rhymes with slope. Yeah, slope. Good. Awesome. Has nothing to do with the Pope, but it has a bigger slope. And the slope, and I asked you, which one's moving faster? And you told me the one with the bigger slope. So apparently the slope has something to do with the speed at which your cars move. Agreed? So, what you're going to be calculating out is the speed at which they move. Now, I know that we've taught you this in 8th grade, and I'm not going to teach it to you right now. And if you need, I can teach it to you now. But if we have at least 2 points, because the graph that you're going to get, you're not going to get, the computer's not going to spit out this pretty line. It's going to spit out something like this. Right? And then you'll have to kind of create a line based off of that. And I'll tell you how to do that. The way you do that is you choose 2 points. And then you just connect those 2 points. And then you can just get the coordinates of this point using that table trick that Keeley suggested. You say the x, you say the y. You look at the x and say that's about at that y. And then from that, you can figure out what the slope is. It's the rise over the run. It's how high you had to go up divided by how far across you had to go. We're cool with this, right? This is not something new I have to teach you, because this isn't the new thing yet. You understand this? All right, now.
That's just line of best fit.
This is line of best fit, exactly, which is a very popular science concept, which comes from math, which is a very important thing. Now, I want you to tell me this. Not everything moves like this, right? It doesn't move in a straight line. It doesn't move at a constant velocity. That would be a very boring world that we live in. Things move differently. One thing moves like this, and you tell me what's going on there. What do you think is happening? Here's the graph. Describe for me the scenario as to what's going on here.
Something's accelerating.
It's accelerating. There we go. You use that word. What does that mean? Accelerating.
It's going faster.
It means it's going faster. When you are at a stoplight and you're like, vroom, vroom, right? None of you are doing that because none of you are driving. But I'm just saying, pretend you're at a stoplight and you vroom, vroom, and then you go, you hit the gas, right? Do you go from 0 to 100 miles an hour instantly?
Like accelerate.
You accelerate. You start off a little, your car goes, and it gets faster and faster and faster and faster, and then finally gets up to 100 miles per hour, right? So in this amount of time, its speed is, its distance is only this much, but in this amount of time, its distance went up by that much. Do you guys see how this acceleration is? Do you guys get it? All right. There's one more thing I want to do before I start teaching you calculus, and it's this. I'm going to use Tejas because I love his enthusiasm. Actually, you know what? I'm going to use Coco, if that's right with you. Coco, draw a line for me, the line that I'm thinking of in my head that goes through that point. Go for it. Come on, I'm going to grab a pen. Draw the line that I'm thinking of in my head that goes through this point. Use purple. It comes out nice. And it matches your ears. Oh, wrong. Try again. Close, but wrong. Draw a line for me that I'm thinking of that goes through that point. That's not a line. Close, though. You guys are seeing I'm giving her an impossible task. I don't know. She can't hear me right now, but she can't do it. Try again. Come on, keep going. Keep going. I'm encouraging her. Keep going. That's absolutely the line I was thinking of in my head. No, it's not. It's not at all. But what I'm saying is, all right, here, thank you very much. What I'm saying is, actually, you know what? Hang out here, because I'm going to let you be successful. Now, draw the line that I'm thinking of that is going through those 2 points. Oh, that is totally it. You got it first try. That's amazing. Everyone give her a hand. Thank you. You can sit down. All right. She can do it with 2 points. She can't do it with 1 point. Why is that?
Because from that 1 point, you don't know which direction.
You don't have enough information. You can't get a line with 1 point. Does that make sense? Everyone agree with that? Everyone can totally agree with that? Like, I understand that. I can't get a line with 1 point. You need at least 2 points to give you enough information about the slope and the intercept to graph that line. Everyone agree? Now, here's the thing we do in calculus, okay? I told you a few concepts, and I want you to start thinking about this. If I want to know the speed at which an object is moving, I need to find the slope of that line, right? That's the first thing I taught you in this new thing. The second thing I showed you is an acceleration graph. But I'm asking you this. What's the slope of this curvy line? If you don't know, say, I don't know. And I'll give you a hint, I don't know either. So everyone say, I don't know. If you don't know, say, I don't know. I have no idea how to find a slope of a curvy line. Us in calculus, we don't even know how to do that either. Does that make sense to you? We can't find the slope of this line because there is no such thing as a slope. It's constantly changing, this slope is, right? Because at this point right here, the slope looks like it would be that, right? But then at that point over here, the slope would be like that, right? So the slope is changing as we go through this. What we can do, however, is find the slope at a certain time. Because let me ask you then, does that mean you never know your speed? Does that mean you can never know your speed? Then how does your speedometer work? If you can never know the slope of your thing, and you have told me that you know about acceleration, speeding up, how does your speedometer work if you can't know your speed? Well, what the speedometer tells you is it tells you the speed at which you are moving at that instant in time. Does that make sense? Right? So like at this point in time you're moving at this speed, but later on you're going to be moving even faster, and then later on you're going to be moving even faster. We cool? So what we can do is we can calculate this thing that we call the instantaneous velocity. It's the slope of the line that is touching this curve at this 1 point. Now we're getting into calculus here, okay? You guys are realizing, wait a second, that's not that bad. Is it that bad?
No.
Did I lose anyone yet?
No.
All right. I'm almost going to be done because I want to give Sarah a little bit extra time for her lecture, like 15 minutes. So I'll be done in 15 minutes. But I did want to explain this concept to you. Here's the problem that we have, and this is what I demonstrated with Coco, is if you want to find the velocity of this curve at this instant in time, that's only 1 point, right? How are we going to calculate the slope of only 1 point? Do you see what my problem is? And I'll show you what we do in calculus. We say, okay, fine. I don't know the slope of that line because it's only 1 point, and you can't define the slope of a line if you only give me 1 point. You need how many? You need 2 points. So why don't we make up another point? We'll have this be 1 point and this be another. Okay? Now think of this purple graph as a wire that's being bent like this. Okay? And think of these green things as beads that are strung on this wire. Can you imagine this in your head? So I can move this green bead along here. Okay? Now I'm going to take some kind of laser pointer and I'm going to draw a line that is going straight through those beads. Do you agree? Can I find the slope of this red line? Why?
Because it's not moving in a
Because I have 2 points. As soon as I have 2 points, I can figure out the rise over the run, and I can figure out what the slope is. Do you agree? Well, how can we make this red line look more like this black line? And I kid you not, this is the first lesson of calculus. You learn in Algebra 1, I just taught you about y equals mx plus b. I taught you about how to find the equations of lines based off of 2 points. I'm teaching you the first lesson of calculus. Raven's suggesting change the coordinates. What do you think she means by that? Raven, you can turn on your microphone and chime in if you want, but start thinking about this.
I think she means like change where the beads are.
Change where the beads are. Okay, all right, what do I do? How do I do that? Move which one? Move the top one.
I think like that. Yeah, that one.
Yeah, that one. Okay, fine. Move that one. Where? Farther away? Up? What should I do?
Down.
Move it down. Okay, so if I move it down, let's say I move it to maybe... Because I'm getting excited. Now I'm thinking like, I didn't think I was going to teach you calculus this morning, but... Now my new red line looks like that. Is that closer? Okay. Now, how can I get it even better? What can I do? Keep saying. Keep
Bring
going.
it down further.
Move it down further. Exactly. So, here's my new green bead. Here's my red line that connects the 2 green beads. Look, it's even closer. So how could I figure out, maybe I might not be able to figure out exactly what that black line is, but how can I get really, really, really close to how can I make this red line be really, 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 really close to what that black line is?
Bring it to where the black line and the purple line
Estimate.
Well, yes, essentially we're doing an estimate, but what we're doing is we're just taking this green bead, the second one, and we're moving it closer and closer and closer and closer and closer to the first bead. Now, I can't move them exactly on the same spot, because if I move them exactly on the same spot, I no longer have a red line, because you can't define the slope of a single point. But I could have 2 points that are really, 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 really close to each other, and I can still figure out what the slope is for that. That's calculus. I can show you the calculus book, and I'll show you the first lesson. That's what it is. So hopefully what that means is that you guys are like, whoa, now I'm not so afraid of it. Raven, ask your question.
So calculus is basically where you move 2 points where they're not touching, but they're really
That's the
close
first
to each other?
lessons of calculus. That's the ideas of calculus. What calculus is doing is we're actually doing the equations of moving things. And guess what? Today in your science lab, you're going to be graphing what kinds of things. Okay, graph the motion of this. Go. No, very boring.
0.
No, that's not what we're doing. We're moving, graph the motion of this. That's motion. When you have motion, you're talking about moving things. You just have to start getting into calculus. Now, that's not to say that Miss Tonanini is going to be like, all right, well, today we're going to be doing graphs of motion, and everyone needs to know their calculus. No. That's not what we're. I don't think that's what she's going to do. But what I'm saying is, you're going to be looking at curves, right? And the question I wanted to ask you is, how does your car figure out what the speed that you're moving at is? And the answer is, well, your car doesn't actually do calculus, but I'm saying, what we do is we take a look at the instantaneous velocity, the velocity you are moving at any given particular point in time. And in order to figure that out, that's the thought process that we went through. But it's nothing harder than y equals mx plus b. Okay? Now, you won't see this in your science class. You will see this in your calculus class. We're going to throw out the word limits, and all that means is get all that means is exactly that concept that you guys figured out. You told me, oh, you just move that bead closer and closer and closer and closer. That's what a limit is.
Can the two beads touch? But even though, because you said they can't be on top of each other, because then it's one.
It's that is called Zeno's paradox. I really like it. As a punishment for my son one time, I said, all right, stand 20 feet away from this wall. And you can come out of timeout when you touch that wall. So I said, what you're going to do is, the rules you have to follow is you stand 20 feet away, now stand 10 feet away. So he walks halfway. Now stand 5 feet away, so he walks halfway. All right, keep going halves until you get to the wall. Then you can come out of timeout, because I was really pissed at him. Right? So he's going to go 5 feet, 2.5 feet, 1 and 2, 1.25 feet. You get closer and closer and closer. Will they ever reach the wall? No, he won't. I think he figured it out. He started crying. Good for you. Learn your lesson. All right, but that's the concept of getting closer and closer and closer and closer, but never really ever making it.
So they can never really touch.
Yeah, I mean, if you think about it, if you always are halving your distance away, will you ever actually get there? I mean, you can even go like, I'm 1 atom away. All right, now I'm half an atom away. Now I'm quarter of an atom away. Now I'm 1 electron away. Now I'm half. I mean, literally, you would actually be touching it physically, but atomically, you could still be. You see what I mean? Like in your mind, it will never actually work. You guys get it? You guys, am I speaking crazy here or?
Makes sense.
All right, we're done with math today. Okay. Raven is asking, what is the equation in calculus? I think that if I wrote that on the board, you might be a little bit intimidated for now. Today, what I'm trying to do is actually kind of take down that intimidation. But actually, you know what? If I had maybe another half hour, I could write that down on the board, the equation for calculus and what I just taught you.
Another half hour?
And explain it to you, and then you would actually know that lesson in calculus.
That's how long the equation is?
No, it's not.
Oh, okay.
No. No, but remember, what I do is I show you y equals mx plus b, and we spend a half hour on that.
Oh, okay.
Right? So I'm going to write this equation down. It's not even that long. It's maybe about this long. But I would talk about it for half an hour, because Mr. Dalde is long-winded and says just lots of things without actually teaching you substance. Right? Now say no. Come on. Like, I'm a good teacher, especially when I'm in front of other teachers.
You taught us substance.
All right, I hope so. All right, anyway. Justice Leanna says hi. She asked me twice to tell you. All right, folks. I hope you enjoyed class today. I enjoyed teaching you. Thank you for coming in.